Well, yes. Hello to everyone who's there, of course. And thank you to HashiCorp, of course, for organising it. My name is Ben, and as Dominique, I think, was saying, I'm going to be trying to talk about Terraform and uh, its use in kind of for database administration in a cloud native world. And I guess I'd just like to start with caveating the truth that, and setting the record straight, that I'm neither a database expert nor a database administrator. I am a developer. I am opinionated, and we've at Tumelo have been going for nearly 3 years now, and so we've seen some changes throughout, and we've kind of had to adjust our database accordingly. And I guess this is some of the learnings of that. And I hope that with that experience, I am not going to give you any best practices, nor am I going to nor is it about performance tips. And I think most people will leave this talk with, I guess, more questions than they had coming in. But I think that's kind of what I want to achieve. And hopefully it gives you more than just questions. It gives you a lot of options and kind of a breadth of kind of places you can go and think about. And hopefully Terraform allows that in part. And so, yeah, so that's really what I'm hopefully leave you with kind of in terms of database administration. Just very quickly about me, because I think it's important just for this talk, because it's kind of a bit of a journey that I've had to kind of go through to learn and understand database administration and kind of how that fits in a cloud native world. So I'm from Luxembourg. I studied physics. I'm a software engineer at Tumelo. And I guess with that background of physics, I kind of jumped into software engineering kind of very quickly and had to turn that around quite quickly and jumped into some people would say some too complicated tech. But I guess that's in a lot of ways where I find myself at home, and you'll see why. And that's just a picture of me at my happiest, kind of playing with motorcycles. So I guess to understand databases and kind of databases in the cloud native world, I kind of started by looking at why I find databases so difficult. And I think this is, well, there's the obvious reasons why. It's stateful. If you lose it and it goes wrong, you lose all the data and there's no coming back from it. But looking at just why they were difficult, that wasn't quite the answer. And so to kind of get the answer to why I thought they were difficult is I looked what I thought was simple. And I personally find Kubernetes and Terraform simple. Now, they're not easy by any stretch of the imagination. That's not what I'm advocating for. But I think because I jumped from that physics kind of background straight into software engineering, into tech like this declarative nature of the two is really where I feel at home. And it's this idea that, and I can't get around it, is kind of, I find it quite simple to be able to tell a piece of computer through a bit of code what to do, not have to figure out imperatively how to do it, and it will do it for me. And so that's kind of where I feel most comfortable. It's also where, I guess, I was talking about jumping quickly into software engineering. If you read a lot of blogs about kind of a startup and where you should start, they obviously say start simple, EC2, kind of with a load balancer, the kind of simple start. But I guess for me, because of that history, that declarative nature is really what I find simple. And if someone asks me to kind of deploy something on an EC2 instance, I turn around and go, shit, how do I worry about health checks? What happens if it goes down? Whereas I feel much more comfortable in a world where I've told a computer in that declarative world how to deploy it. So kind of, I guess that's kind of one bit of my journey. And then I guess trying to look into deeper databases, I did some basic reading on cloud databases, as I think most people should. And note that I haven't said cloud databases because I think that's very important. And the way I kind of started this was by looking at a book called An Introduction to Cloud Databases, which is from AWS, and kind of AWS have sponsored. But it's very much a kind of a traditional move to the cloud way of thinking. It's sort of this picture here where cloud database administrators were obviously traditionally tasked with kind of putting RAM in a box and kind of putting it in a rack and kind of making sure that worked, and the layers on top of that were needed as well, but that's where kind of a lot of time was spent. And in this cloud world, we've kind of moved to, as this picture shows that I've nicked, people have more time to focus on the application. And so that's absolutely great. And from the book, I've kind of looked at some of the tasks that I guess, some of which were the traditional tasks that the book mentions, installing racks and that sort of stuff. And you can kind of see some of it is also kind of the application side of it. And then when you move to the cloud and you move to something like RDS, you get a set of new tasks. You get kind of deciding on that cloud architecture, deciding on the regions, the operational costs, kind of you have to deal with the IM system, you have to deal with often with VPCs, if you kind of picture an EC2, a VM with a database setup. And I think having read this, it was quite obvious why Terraform is such a good tool for this, although the book mentions CloudFormation. These are things that I think a lot of us are quite comfortable doing in Terraform, IAM roles and that sort. And so I guess kind of the book at the end of it mentions CloudFormation, but to me, that's kind of Terraform. So I guess those are kind of the first two bits of the story. And to me, that kind of gets us to the cloud, that gets us, or me personally, in kind of a world where I understand why databases are so hard and why a lot of the tech that we kind of are used to doesn't work in that world. But I kind of wanted a bit more, and we've pushed a bit further at Tumelo. So, and to kind of answer that question, I think we really had to go back to basics. Something as simple as, what is MySQL? And I think this, like I hope a lot of people are looking at me like surprised and saying, shit, of course, he's not a database expert. Why is he asking this basic question? And I think rightly so. But at its core, I guess we all think of it as a database. We think of it as MySQL as being this, I've simplified this, of course, but kind of a binary that you execute, that once you've executed, it kind of starts building some storage and it attaches itself to the port. And that's very much the image of MySQL I had. And I think because you're in a cloud native world, a lot of us kind of it's not too far of a stretch to kind of go, well, let's put it in a Docker image. And so that's still very much the binary, that sort of world of MySQL. And that's still the picture of MySQL that all of this kind of has. I think you can move on to that slightly, and within the binary and within MySQL, you have these ideas of replication, you have these ideas of backups and these different systems. So it goes slightly beyond. And if you go to kind of the MySQL website, you see there's quite a few options of how I guess you can deploy the binary, this kind of traditional idea of MySQL and the binary. And I guess in my head, that's kind of MySQL exhausted. And I think that's where I'm wrong, or I was wrong. And I think where you can go a lot further, and by thinking slightly more abstractly, you can kind of get to a more interesting point. So initially, I obviously thought this was kind of that binary idea exhausted. And then I was introduced to these few next pieces that are kind of very different, but still, I think, MySQL. So for example, here we've got an idea, an architecture diagram of a product called Vitesse, which is kind of a horizontal scaling and management layer for MySQL. And although from the application point of view, as it shows on the diagram, if you talk to Vitesse, it appears like it's talking to one MySQL instance. Under the hood, it's essentially this network of MySQL databases that are shown here as the MySQL D, which is kind of MySQL daemon, with all these kind of I think they're Go-based management tools. And so to me, this kind of extends the idea of MySQL. It's no longer this binary. It's kind of, from the application's point of view, it's still MySQL. But we've kind of completely taken apart the way it works underneath it. And I think this is a great example of kind of it going further, but this still uses the binary. There's even examples of this idea of the binary, there's even examples where people have gone further. And so, for example, here, this is AWS Aurora. It's a database solution from AWS, and they've kind of redesigned, rethought about how you store a database. And I think this is really interesting because, again, from a client's point of view and the application's point of view, it's still MySQL. And it's really cool MySQL because you can even buy this in a serverless form and pay for it kind of on a serverless basis, but it's still MySQL. And so what I've kind of, in my journey, I kind of got to the point, I'm getting to the point where MySQL is no longer this little binary, or this binary that kind of you associate with a database. It's kind of a lot more than that. And I guess those are kind of different dimensions of MySQL. And I think the last dimension that I really like to think about is kind of how you access it and how you communicate with your database. And this diagram, I guess, tries to illustrate the different ways you could talk to a Cloud SQL database on Google. So on the left, that's supposed to kind of, I guess, illustrate kind of connecting over the internet, possibly over SSH through a service to that database. The second one is on a VPC, nothing too unusual, and kind of still within the confines of what that traditional binary kind of you expect to do with. But then Google has added its own layers on top, and that's what the third and the fourth kind of diagrams are. And the third one, I guess, is trying to illustrate the idea that Google provides a Go proxy that you can run by your service, and that proxy with the right IAM credentials will tunnel an SQL connection to that database, so you don't have to expose it to the internet, for example, or not have to expose it to a VPC. So I guess that's another way of connecting to it. And then the last one is kind of taking the third one slightly to another level, where we've kind of adopted and absorbed that proxy into the Go code itself. There is a Go library called Go Cloud, where if you kind of set your connection to the database through it, it will tunnel it automatically. And so I guess what I'm getting to is the idea that MySQL, although I originally pictured this binary sort of this concept, it's in a cloud native world. And here I use the cloud native word very deliberately. There's these different dimensions that allow you to run it so very flexibly and so in such different iterations. So I guess in my head, I'm kind of picturing the language component, which I guess you could argue is kind of like SQL, but I think there's more to it than just SQL. And then there's the tunneling aspect that we were kind of just discussing about, is how do you talk to MySQL? And that's something the database administrator has to think about as well. And then I guess there's this huge package that I don't think is quite given justice with kind of the term storage, but what does it look like on the flip side, where on the side of kind of the application can't see? And that's things like the Aurora is a different implementation of the storage, or kind of Vitesse, or replicas. And so you have these different options that together kind of make this very dynamic, very flexible system that you can kind of take from a Docker image all the way to kind of a crazily, massively scalable system that's used by Google, by YouTube, Vitesse, for their database needs. And that's kind of where I've gotten to. And I think that's, in my mind, is where you transition from MySQL being a cloud database to a cloud native database, and you get all those benefits and that agility. And again, like a serverless version of it is an incredible thing to be able to use if that's a really good use case for you, where you've got very spiky traffic. So I thought the best place to go the next is kind of try and use all that, I guess, that journey and that knowledge and kind of to our advantage, and see the options that, for example, in a fairly limited problem, a database administrator or kind of a developer with that database administrator could think about. So I guess it's a bit of a tenancy problem. And so if you picture, for example, a very simple use case, you have these two services. We work, Tumelo is in the kind of financial space, and we kind of look at people's instrument holdings, instrument being like a share or a bond. And so we have two services. One is the instrument service, which holds the information about that share or that bond, kind of globally true information. It uses a Postgres database as kind of its storage layer. And then we've got another service which holds essentially a user's account holdings, and it's kind of very different use case because it's sensitive user information. It's kind of subject to data protection laws. If we were to go global, like, we'd have to be worrying about tenancy, but similarly kind of uses a Postgres database. So kind of those two things that are together share that column, which is obviously the identifier for the instrument. And so I guess the question we often kind of come into is, how much do we want to split this? How separate do these things need to be? And so if you we can go through the gamut, I guess, of it. And if we look at the kind of Terraform, and this is now very in Terraform, if we look at the kind of Google provider, you've got the kind of traditional ways you can split up these things. We could go, I guess, to the extreme where we're splitting up projects. So here, this is an example where we've got kind of two separate databases in completely separate projects. So they're completely isolated. In this case, kind of bringing them slightly closer together, we've got one project with two databases, but still two separate instances. And then we can, with this Google provider, and I'm sure the AWS provider and the Azure providers or any other cloud providers kind of present the same kind of interfaces, you can get to possibly the point of having two separate databases within the same instance as is shown here. But I guess we wanted to go slightly further, and we wanted to do that again with all the learnings of kind of still declarative, still Terraform, wide move tools. And so I guess this is where the Terraform Postgres provider came in for us. I've included that name there, Cyril's name there, because it used to be, I think, managed by Terraform, and I think not by Terraform, by HashiCorp. It's kind of been handed over to Cyril to run it. But we had one big problem, and the problem was that we had these cloud databases that we were always accessing through proxies. We were using the Google AIM solutions to access these proxies, to access these databases without having to expose them on the internet. Now, that we didn't want to expose our databases on the internet to kind of manage them, nor did we think it was appropriate to kind of build, I guess if you've really tried, you could kind of build scripts to kind of periodically or like momentarily expose the database. But I guess taking that knowledge that we'd built about what we think of a database being, we thought, well, why don't we use that library, that Go Cloud library that we're using everywhere else, and put it in this Terraform provider and think of it as kind of this tunneling layer. And again, I think I kind of push that Go Cloud layer, but Cyril and some other people definitely pushed it across the line. So now if you look at the Postgres provider that is maintained, we have this idea of a GCP, of a scheme, and it's kind of it kind of replicates the idea of the tunnel, and you can kind of define the tunnel. And so, for example, here what we're saying is we essentially tunnel through this GCP Postgres tunneling system to that particular host and use those username and passwords for Postgres. And this is merged in, and it uses the Go Cloud library under the hood. But what it gives us is some neat little tricks. Again, this is kind of us prototyping the thing directly. And what it has allowed us to do is, without ever having to expose our database to the internet, and with using the IAM credentials that you can just build or define in Terraform, we can now take that Postgres provider and apply it to these Postgres, these managed Postgres instances. And so here's an example of kind of us creating a Postgres database on that Postgres instance, using a role, building a role, and then also granting that role some things. So you can picture, for example, just like you would do with IAM roles, you can create Postgres roles and grant them permissions and manage them in that way, as well as kind of schemas and things like that. So I guess we can kind of do a quick demo of what that can look like and what that workflow can look like. So yeah, if we look here, so what I've built, so I've got so let's start off with this local Terraform instance. I've got a database that I'm connecting to. I've referenced the Cyril's provider, connecting to it, and then I've essentially built this database module. And in this module, we can use the different pieces, just like you would any other Terraform module, and all these different resources that you can kind of put together. And so for example, what I've tried to illustrate here is the idea that we are creating a read. We are creating two databases, one for the user accounts, as I was describing, and one for the instrument service. And then you can create a read-only user for those databases. I hope this is readable. I can't really get any feedback. But that's kind of the idea. And we've defined this all in Terraform. And the nice thing about this is, as you see, I've kind of connected to my local database here. You can, because again, I think a cloud native idea, we can do all these things locally. We can iterate on them and see those changes locally. And again, you kind of get the full Terraform benefits of seeing all these different pieces being created and being deleted, and you can also see them in real time being created here. And that's kind of a really nice workflow, because I don't know, suppose I now want to delete this user. Let's not do that. Suppose I want to delete you can see the databases. It's useful. Here, I hope. No, that's not what I'm doing. You can see the databases, of course, here and here. You could delete one of them, iterate. Something's not quite right. Never do a live demo. I guess you get the point. You can kind of iterate on them, create them, you see them appear here, and then you can, the nice thing as well is, because it's kind of cloud native, I worked on it locally, and now I want to deploy this to my Google instance. So what I've done here in this kind of more environment one is I've kind of set up a Google Cloud managed SQL instance. I then connect to it through this bit here, and then I'm importing this path here. So this work that I have done locally, I can also apply to just as easily to my database online. Now, this is probably not going to work, I'm sure it isn't, because I've been messing around with it, but I hope you get the idea. And then to kind of, I guess, to finish it off, what I promised you at the beginning was kind of options, and what Terraform gives you is this massive range of options. We've just seen kind of this tenancy problem that we've divided kind of from a provider level, or kind of we can divide at a provider level, but we've shown kind of project, region, databases, all the way down to a schema in that split. And that's all with one tool, which I think is hugely powerful. And I think we're running out of time. So thank you very much. And I guess I'll stop sharing.